I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Ted McKlveen, co-founder and CEO of Verne. Verne's building the future of low-cost hydrogen by using compression technology. When the cost of hydrogen lowers, the adaptability increases, the scalability increases, and the adoption increases. Tune in today to learn about the future of hydrogen. We hope you enjoy this episode. Ted, welcome to the podcast.
Hi, great. Thanks for having me.
It's great to have you here. We're both inspired by a love of some of the world's greatest novels written by Mr. Jules Verne. And it just so happens Mr. Verne's novel, Mysterious Island, influenced the founding of the company. Were you reading the book one day and came across the hydrogen paragraph, or how did that start this whole journey for naming the company Verne?
Yeah, it was really almost the other way around, where we were really motivated to start a hydrogen company, a hydrogen storage company, and wanted to name it after something fun, something kind of inspirational. And that's where we came across Mysterious Island. And Jules Verne back in 1875 mentioned how hydrogen could replace coal as a fuel source of the future. So I thought that was a fun really tidbit there that we could lean on and name the company after Jules Verne. If
you look at some of the famous novels, 20,000 Leagues Under the Sea of Around the World in 80 Days, and there was a common denominator, Mr. Verne was ahead of his time, dramatically ahead of his time. Why and how do you think he was so far ahead of his time for what he wrote in the 1800s?
Well, I do think he had a good imagination. Of course, it's what makes the books pretty fun to read, but he actually in some ways he wasn't the first one to come up with this idea of hydrogen being a good fuel source. The first hydrogen fuel cell was invented nearly 30 years before he wrote the book. So hydrogen as a concept, as an energy carrier, has been around for almost 200 years now. We're really just seeing it really emerge now as a replacement to oil and some of these fossil fuels we have, as we're learning some of the environmental reasons to do so. But I think, Jules must have been pretty well read in his day, seen some of the promise of these technologies that were really cutting edge even back then. But certainly, well above ahead of his time there by 150 years or so.
When you're sitting there thinking the idea that you said, okay, I want to build something, I want to put on my builder hat, why did you decide to build a hydrogen company? What was the motivation behind that?
Really, the motivation for me is all about environmental protection. So we've seen the impacts of climate change, and they're only increasing. Just now as we're recording this, a lot of big hurricanes hitting the U.S., wildfires out here in California where I'm based, and so it's all been about environmental protection. I used to work actually in renewable energy, and while that's also important work for environmental protection, electricity today is only about 30% of the U.S.'s emissions. And I really wanted to address some of the other emissions in the economy, whether that's transportation or heavy industrial. And hydrogen can really help address both of those sectors. It really seemed like an underserved part of our emissions that needed a lot more attention directed to it.
Hydrogen's always been this big tease, a lot of promise, a lot of stuff. Say, I'm going to tackle hydrogen, and then funding dries up. I'm going to tackle hydrogen, and then funding dries up, and just seems to be this common trend. But you and I both know there's a lot of promise with hydrogen. The facts are there, the data's there. What ultimately has to be done to unlock hydrogen? Is it having a patient investor that believes in this, or is it getting OEMs to adapt it, or getting a fueling infrastructure? What has to be done to truly unlock the true promise of hydrogen?
Well, ultimately, it all comes down to hydrogen being an economic solution. People will say that they'll switch over to hydrogen for environmental benefits, and that's really why you should switch, but it has to be economical. All these end users of hydrogen operate in industries with pretty slim margins, and they don't have a lot of ability to take on extra cost. So hydrogen has to become cheaper. It has to become cheaper to use in any of these end use applications. Some of that comes with scale. And so it's really what's going to stimulate the hydrogen economy scaling, just so that it can get to economies of scale and drive the cost down. That's a lot of where some of the government's investments in hydrogen hubs or tax credits to stimulate hydrogen can really help. That's a difference now versus what we saw maybe 20 years ago during one of the last hydrogen hype cycles. And it's really similar to how you see solar and wind having taken off here in the US with federal investment that really helped stimulate those technologies to grow and get them moving down these learning curves and get them to scale economies. So that's certainly going to help, is some of the stimulation to get the industry moving and reach these scale economies. But ultimately, what we really need is hydrogen to be economical, not only at the point of production, but also at the point of usage. For hydrogen fuel cell vehicles, it has to be cheap at the pump, not just where it's produced. Or for some of these other specialty and industrial applications, it has to be cheap where they actually are using the hydrogen. And that's a lot of where Verne comes in. That's actually why we started the company, is to make sure that we could actually deliver the molecules to the end users in as cheap of a way as possible.
How are you doing that? Is that your cryo-compressed technology, or how are you looking to achieve that?
Exactly. That's our cryo-compressed hydrogen storage technology. So if you think about delivering a molecule of hydrogen from a producer to an end user, you have to do a couple things. First, you have to take this gas, this hydrogen gas, and densify it into a really high density state, store it in storage tanks, hydrogen storage tanks, and then drive it on a truck to the end user, such as to the fuel station. Now, there's really two things that drive the cost of delivering hydrogen in that way. One is the truck trips. How many truckloads does it take to deliver these hydrogen molecules to your end user, your fuel station or industrial user? And the more truckloads it takes to deliver the molecule, of course, the more expensive. The other is the cost of densifying the hydrogen. You can think of that as compression or liquefaction, getting the hydrogen into this high density form. So what we've innovated on and solved here really is how you can address both cost elements. First, we store hydrogen in a really high density. That means you can minimize the number of truckloads it takes to deliver hydrogen to a user. So this high density, you can get a lot of hydrogen on each truck and deliver that at really high volumes and low cost to an end user. But on the upstream side of that, we actually do that densification also incredibly cheaply. So about 65% less cost in densifying relative to liquefying the hydrogen. So with cryocompression, we're really minimizing the cost for the entire delivery of the molecule.
Are you the zip file technology for hydrogen? Because when you make a zip file and you zip it and compress it, it's cheaper. Well, cheaper. It is cheaper to send it over the internet. It's faster. And so what you're describing is cheaper and faster. So are you the zip file, .zip?
Yeah, that's a great way to think about it. I haven't heard that one before, but yeah, the zip file for hydrogen.
So staying on the zip file theme, when you deliver the hydrogen to, let's say, a storage facility or to a refueling facility, how do you unzip it? Is that another technology that you have where you uncompress it or unzip it?
No, you don't need anything on the receiving end, and no special technology. So essentially, we store it as a cold compressed gas. So it's essentially what our technology looks like on the truck, on the trailer, is an insulated compressed gas storage tank. So it's stored as this cold compressed gas. And then when it gets to its end application, you can very easily step down the pressure just using a standard regulator. Now that's also part of the trailer. It's just you use a regulator and then you can dispense the hydrogen out of the trailer to your end use at whatever pressure you want. We also warm it up and so it has to be ambient temperature and low pressure for a lot of applications, or sometimes high pressure, but we can get to that end state with a regulator and a heater just to make sure that the hydrogen is at the right state for the end user. It doesn't require anything to be at the end user's site though, specifically. All that's kind of built into the trailer, and it's pretty straightforward to increase the temperature and decrease the pressure.
What type of storage facility is needed on the other end? So the trailer is, you have a 70-foot trailer, 55-foot trailer. How much storage space is needed when you deliver a full trailer to your end customer?
There's a few different configurations you can have. Some end customers like to do a trailer swap. So you can essentially just leave the trailer there and then take an empty trailer back to wherever you started. You could also have an array of tanks at the site. Will really depend on the end user's volume requirements. If we're taking the hydrogen to industrial user that is using 250 kilograms of hydrogen a day, then maybe a trailer swap is sufficient, or a small tank array on site. If it's to a major truck stop, then they would need a lot more storage. So it really depends on the end user's volume. What the storage tank actually looks like on site could be one of two things. It could be more of our storage tanks, our cryo-compressed hydrogen storage tanks. So you could have a setup of buffer tanks at a site for receptacle storage tanks, or you could have compressed hydrogen tanks, because we could dispense into that as well. So either are options there. And there's compressed tanks or cryo-compressed tanks.
Let's call it the Verne system. Could the Verne system be used as a backup system for the energy grid, for data centers? So you're not having to rely on nat gas, you're not having to rely on diesel generators. Could a company essentially put in what's called a Verne system and use that as a backup in the case of a potential power outage?
Yeah, we've been actually getting a fair bit of interest in that application, using hydrogen essentially as a virtual power line, if you will, a carrier for electrons to an end user. You can take the hydrogen, deliver it at low cost to an end location, and use that to power a fuel cell or a hydrogen engine to generate electricity, divorced from the grid, independent from the grid. So whether that's backup power or even just remote power in locations that don't have grid access, things like off-road segments. You have a new construction site that needs to power their floodlights and equipment on site. Instead of using a diesel generator, you could use delivered hydrogen and a fuel cell.
It's cleaner. What type of usage are you getting compared to a typical generator? Are you going to get more usage? Obviously, we know that you're going to get cleaner usage, but can you potentially get hours and perhaps days, depending on, obviously I know the draw, but on the application, just say if you put one truck or one tank?
In terms of the hours of operations impact that we would have on a generator, we see this as it could just replace the existing generator's current load and its hours of operations, or it could expand some of the use cases as well. We see a lot of electricity load growth growing in the U.S. right now with data centers coming online and with electric vehicles. And so the grid is strained, and we see that this solution could solve some of the strain on the grid. Of course, the grid will grow as well, but perhaps not fast enough, and to the extent required to actually serve all of these end power requirements.
Due to hydrogen being flammable, what safety measures have to be put in place when the hydrogen is being stored on a site? Yeah,
there's codes and standards for hydrogen storage on site and for safety. Really, we think of it like any fuel. Fuels are energy dense, and that means that they're combustible. The same is true with diesel and natural gas, other fuels. It really all comes down to engineering specifically for the safety considerations of the fuel type. So we follow applicable standards, safety standards for our technology for hydrogen that has everything from ensuring that the vessels are overrated with their safety factor to contain the hydrogen, and having multiple redundancy fail safes for hydrogen venting if that needs to occur. So all that to say, there's good experience with hydrogen in industry today, a lot of safe experience with handling and moving and storing hydrogen. And you can think about it just like any other fuel. People store compressed natural gas on site. They store propane on site. They store diesel on site. And similarly, there's a way to store hydrogen safely on site.
If you're staying on the diesel theme, if you look at an industry, they get drunk on diesel. They use it all the time. It's the Class 8 long-haul trucking. They drink it by an oversized straw. They're constantly using lots of diesel. And when you speak to Class 8 trucking executives, fleets, carriers, they're all looking for alternative forms. They've explored electrification. But unfortunately, you and I both know, massive range limitation, weight limitation issues. And there is a large desire from a lot of the executives in trucking for hydrogen. Do you see your technology developing with Verne and hydrogen in general eventually being deployed on Class 8 and then eventually Class 6 trucks?
Yes to both. And we're doing the same thing as you are. There are some trucks that go short ranges that carry lighter payloads, and they can be electrified pretty readily with a battery electric solution. But in the Class 8 segment, there are a lot of trucks that do go long haul. They go far ranges or are payload constrained. And both of those segments really do require an energy dense fuel like hydrogen. So that is a segment that we've received a lot of interest in. We've worked with a couple of the major truck manufacturers in the space on projects together. So there's definitely recognition within the industry that this is important. What we've actually also recently done is installed one of our tanks on a Class 8 truck as well. It was actually a dual fuel truck. It was a diesel, a hydrogen dual fuel truck. And so installed one of our cryo-compressed hydrogen tanks, frame-mounted configuration on that vehicle. So we're getting a lot of interest there. I think the only thing holding back the industry right now really is the fuel price at the pump. The hydrogen price is too high for it to be close to an economical decision for the industry. And that's where we are also helping to address that challenge with the minimizing the hydrogen delivery cost. A lot of the high fuel price at the pump today is driven by the delivery cost of the hydrogen. So we're working to address both the on-vehicle challenges as well as the hydrogen fuel price challenges.
Is it your compression technology that can ultimately lower the delivery cost for hydrogen?
That's right. Yeah. So by storing hydrogen at such high density, we can minimize the delivery cost. So the high density storage means that we can store a lot per truckload of hydrogen and really minimize that delivered cost of hydrogen to the fuel station.
If you look at California, when Governor Arnold Schwarzenegger was governor of California, he famously wanted to build the hydrogen highway. Is that what it's going to take? Is there going to have to be, if you look at the I-10, a very famous trucking corridor in the South, is it going to have to, everybody talks about, oh, we're going to electrify a corridor, but now I'm going to put my hydrogen hat on. Do you have to hydrogenize a corridor to really have that adoption following the model that California was trying with the hydrogen highway? Then you can go to the pilots, the loves, and then deliver all this, then run it as a model to prove this can scale to other major trucking lanes. Or if you look at the I-75 in Dallas or the 45, we can go down all the famous trucking lanes. Is that what this is going to take?
Yeah, that's a great way to stimulate the industry, is to have specific regions and corridors where there's sufficient density of fueling such that the fleets can procure the hydrogen trucks. We're seeing that take place now actually on the I-5 and some of the routes to the I-5 from the ports within California, but on the I-5 all the way up to Washington as well. So there's funding from the government, the federal government, as part of the bipartisan infrastructure law that allocated $7 billion for hydrogen hubs. Two of these hydrogen hubs are, well, one's in California and another is in the Pacific Northwest. And one of the major focuses of these two hubs is to create this hydrogen corridor on the hydrogen freight corridor that goes north to south along the West Coast on the I-5. So there's some good federal funding that is going towards the rollout of the freight hydrogen corridor that will really help stimulate the market. The other thing that will help stimulate the market and really allow it to grow is some of these drayage routes that we're seeing within California already today. There's actually, so Nikola has actually deployed a lot of hydrogen trucks, more than many people might realize. Just this year, they're well over 100. I think they're almost up to 200 hydrogen trucks so far this year. And they're largely focused in the drayage applications around Southern California, Port of Long Beach, Port of LA. A lot of those trucks are weight constrained. They really can't have the high weight battery on the vehicle. So they're switching to hydrogen. One of the benefits there is that you don't need that many fuel stations. It's just going to and from the port and inland. And so with the network of hydrogen fuel stations that Nikola has actually built out already, it's sufficient to actually stimulate some of this hydrogen trucking demand.
If you look at the Port of LA, Long Beach, San Pedro, a very common route for drayage is the port to the Inland Empire, where I forget the statistic, but I believe there's more warehouses per capacity of anywhere else in the United States out there. I don't have the exact statistics. There's a lot now in Fontana. They're building another logistics center. Do you have to put, so this is a hypothetical, Verne puts a fueling station out in the Inland Empire, and then you put one at the port. Is that then the truck goes out, refuels in the Inland Empire, and then goes back to the port and refuel? Or do you view that you're going to have enough range to go back and forth where you're only going to need just to have a fueling station, say at the port, for example?
You can just have a fueling station in one of the two locations. It could be just the Inland Empire, and that's more where some of the stations are being built today, is on the inland side. And that range you can get with a hydrogen truck is certainly sufficient. I mean, right now, the current models of hydrogen trucks that are available have a range around 450 or 500 miles. So that's a lot of truck trips to and from the port. With our cryo-compressed technology, we double the density of the hydrogen, so we could double that range. Now, there's two ways you can handle that. You could either double the range, or you could get away with half as many hydrogen tanks on the truck, which makes it even lighter. And so it really depends on the use case, the type of truck fleet that that is buying the vehicle. If you're a weight constrained fleet, we can have a truck that's 500 miles, equivalent mileage, but with half as many tanks, saving a lot of weight on the vehicle. If you're a long haul fleet, you can keep the same number of tanks, but store twice as much hydrogen and really drive for that full 850 plus miles that you need to.
The beauty of that is then the carrier can add more weight and make more revenue. So there's a huge benefit there. Let's two math equations here. You take a 500-mile hydrogen truck running the Verne technology. How long does that take? And the second math equation is how long does it take to refuel that 1,000-mile hydrogen truck when you get to the refueling station?
Yeah, so if you have a 500-mile truck, the rough fueling speed, kind of rule of thumb, is about 10 kilograms per minute, and a truck can go about 10 miles per kilogram. So a 500-mile truck is about 50 kilograms stored. You can do that in about 5 minutes of refueling. Okay, so
you're 5 minutes for 500 miles, 10 minutes for 1,000 miles. Why is that not talked about enough? Because if you look at I'm going to go back to the electrification side. You're not charging a Tesla Semi or a battery electric Class 8 in 5 minutes. Let's just call, I don't care if you got Willy Wonka speed supercharger, you're not going to do it. So why is the hydrogen industry saying, look, because you know this, the trucking industry, downtime plays a very important role in your financial models. Why is there not enough discussion around between 5 to 10 minutes, you can have this thing refueled and rocking and rolling?
Yeah, it's substantially faster. And sometimes the metrics you'll hear quoted will be, you can get to X% full of your battery in 90 minutes or things along those lines. The way I really like to compare things is to have really an apples to apples comparison on how much fueling power, how many miles per minute you can actually refuel. And when you look at it in that metric, hydrogen fueling speed is anywhere from 20 to 100 times faster than a current charger, depending on if you're at a high-speed fast charger, super fast charger, megawatt charging initiative, or at a more standard 200 kilowatt charger. It's significantly, 20 to 100 times is not, that's a significant speed improvement in charging. I think the industry understands this. They know that hydrogen can fuel incredibly quickly, which is why, as you mentioned, a lot of the trucking fleet executives are interested in hydrogen. I think right now what's really prohibiting them from jumping on and jumping into hydrogen really is that hydrogen fuel cost at the pump. So they know there's a lot of value there. They just need the fuel to be cheaper.
If hydrogen was par to WTI, excess intermediate crude, for the diesel price, if it was at par, do you think that there would be a switch over, or are we going to run into the infrastructure issue if hydrogen is at par to the current price of diesel?
Yeah, if it's at par, I do think we'd see a switch over. Actually, I think there's some analysis that shows it could be around $4 or $5 per kilogram, a bit more expensive than the cost of diesel, and the total cost of ownership would still be lower than a diesel truck, lower maintenance and a few other factors to take into account. But if it's at that cost parity, I do really believe we would see a pretty significant movement over to hydrogen. The infrastructure is being built out. There's companies that know how to build this infrastructure. So I think really what would get the industry to move would be lowering the cost of hydrogen at the pump, which again is why we're so focused on that. There's hydrogen today, it costs a few dollars per kilogram to produce, but it will cost anywhere between 5, 10, even more to deliver. And so a lot of the cost is coming from that delivery portion of the cost stack, which is why we're so focused on bringing that down.
Will the OEMs then start to accelerate their plans? And I'll just say this very bluntly, the OEMs seem to have this love affair with electrification, and hydrogen was put by the wayside. But when you actually talk to the individuals that buy the trucks, they're much more interested in a hydrogen truck. If it is at parity, then does that accelerate the OEMs because they get the pressure from their large customers? And as you know, when these trucking fleets place an order, they're substantial orders. It's not you and I walking in, hi, I like one truck. It's in the hundreds and sometimes in the thousands based on what they order.
Yeah, well, I would say all the OEMs are actively working on hydrogen. All of the big five, even just today, this morning, H2 Accelerate, part of a consortium in Europe that has Daimler, Volvo, Iveco as members, put out another big report on the hydrogen takeoff, hydrogen economy. And they all have expensive and active programs going on to develop their hydrogen vehicles. So they're definitely working on it. And could they further accelerate? Sure, I think they could further accelerate. I think a lot of the thinking within the industry has been battery electric is a low-hanging fruit. Let's just, build off the back of everything that's gone on in the automotive sector, build a battery electric truck and get that to grow in the industry. What I think we've seen is that actually the uptake of battery electric has been a bit slower than people expected. Some of that's due to the vehicle costs. Some of that's due to the access to the power that's required to charge. Various reasons behind why the uptake has been a bit slower than anticipated. So I already think we're starting to see some of the reaction from some of the OEMs to say, okay, we do need an alternative within the portfolio and need it soon. As I was mentioning there, the charging, I think that almost gets back to one of your other questions on could hydrogen delivery, what we're focused on at Verne, be really an alternative to a power line? And in this sense, it could. And that's one of the real values there is similar to diesel today. Diesel is a molecule that shows up at a fuel station in a tanker truck. When you build a new diesel station, you don't need to connect into the grid. You don't have to go through a utility and go through that whole process. Well, same thing with a hydrogen station. You can deliver the molecule to the location without having to worry about the local power availability. So that's one of the benefits that we believe is going to be increasingly important as the grid gets more constrained and as you have more and more demand for clean vehicles.
Do you view it as from a corporate strategy or planning standpoint, some corporations will look to have hydrogen backup on site for their offices and their various use cases because it is off the grid? Because as we've seen, the grid goes up, grid goes down. And a lot of these businesses are very time sensitive for certain applications, especially when you get into data centers and AI and all of that power that's needed.
Yeah, so Microsoft has done a public demonstration of a hydrogen backup power for a data center. And some of the other hydrogen backup power projects that have also taken place are on cell towers, for instance, just to have that backup power to ensure the cell towers stay active. Different reasons for hydrogen in some of these applications as well. Some of the cell tower applications are for urban environments where noise and pollution are concerned with diesel gensets. So there's actually a lot of backup power applications for hydrogen as well. It will replace all backup power, maybe not, but it's certainly a good additional option for certain applications.
So if you look at cell towers, you got Crown Castle, basically they're a giant REIT company because they sell the land, but you do have land around those cell towers. Some of it's owned, some of it's from a regulatory standpoint. Let's hypothetically say there's a Verne hydrogen backup storage at one, and it runs for a certain period of time, then you just get an alert and then you go refuel it when it's needed. The hydrogen is not going to go bad is what I'm trying to get at. It can sit there for months or years, or is there a time limit on it if it goes bad?
Yeah, the hydrogen can sit there and we would need to refill it once it starts to be used. You need to have a good robust supply chain there in case, just as any backup fuel you would, right? As soon as you start to use the backup fuel, you got to go and replenish it. So that would be how it would work. Now, hydrogen as a molecule itself, it doesn't go sour or stale or anything like that. You can keep using it, and it can sit in a tank for a long time. Part of one of the innovations or the innovative aspects behind cryo-compression was a longer hold time before any venting is required. So if you look at an alternative hydrogen storage method, liquid hydrogen starts to boil after a few hours in a tank. It's a liquid at negative 250 Celsius. So it's negative 253 degrees Celsius. It's incredibly cold. So that means that even though if it's a highly insulated tank, heat's going to get in and then it boils and you start to lose it and it vents. So that liquid hydrogen wouldn't be a great backup fuel because it starts to vent over time. So as storing it as a cryo-compressed gas, a cold compressed gas, we don't have to worry about boiling. It's already a gas. It is cold though. And so the applications where cryo-compressed makes the most sense is applications where you're going to use the hydrogen within, call it a week or so. And so you wouldn't want it just to sit there and warm up over the course of a year, because then you would have to vent some of the hydrogen to relieve the pressure. So there are a certain subset of applications where cryocompression is the best technology. That's for delivering hydrogen at low cost. It's on a vehicle as the fuel tank, and some of these stationary storage applications. There's other stationary storage applications that quite honestly should be compressed hydrogen, just a standard compressed hydrogen tank. That's also something we build at Verne, but it's not really our innovative aspect as much.
Staying on the transportation theme, what about long haul rail? So we had long haul trucks, then the other side is long haul rail. Could your system go on the long haul rail? Some of these trains, I'll keep in mind to our listeners, they go on over a mile. They're pretty long and they take a lot of energy. As the kids book, I think I can. It's a lot of power to move those trains.
It is, and it's interesting. If you look at the rail decarbonization globally, a lot of rail internationally is electrified. But in the U.S., only about 1% of rail is electrified, or some minuscule portion around that order of magnitude. And that's because there's long stretches of rail in the U.S. that are quite remote. You think about crossing the country, be incredibly expensive to electrify that whole track. Expensive given the volume of rail traffic that goes over these long remote stretches of track. So rail is certainly looking into alternative fuels. They're looking into hydrogen, and cryo-compressed could be a viable and good option for rail as well.
Could your technology be retrofitted onto an existing train, or would a train have to be built from the ground up to incorporate your technology?
It would likely be a new locomotive altogether. Locomotives now are diesel electric, so it's diesel running electric motor. And one of the benefits of switching that technology to hydrogen is you could keep the same motor, right? It's still an electric motor that's providing the propulsion. Now, we would change the diesel engine for a hydrogen fuel cell or a hydrogen engine, and then our storage system. So it wouldn't actually be as big of a change as in a lot of the automotive or trucking sector, where today that you're getting that motive power, that mechanical power directly from the motor to the wheel. In the train, there's already that electric motor in place, and so it would be a smaller change in some regard. But it would likely be a new build, just based on the cost of these these locomotives and the overall engineering design. Likely going to be a new build.
Well, change is going to come. I mean, all these industries are changing. The fuel sources are changing. The interfaces are changing. The way these industries adapt to new technologies is changing, and hydrogen will play a role in there. I think it's not a matter of if, it's just a matter of when. It's a matter of when does this technology scale. Ted, in your opinion, what does the future of hydrogen look like?
Well, I think you said it. We know that the economy does need to change. And so it has to adapt to be a lower carbon version of the economy. And hydrogen is really a unique element, a unique way for us to achieve this low carbon economy. It's a molecule that you can fuel quickly. You can deliver it to where it's needed. It's very energy dense, so you can store a lot of power in a light and small volume. So it has all these properties that are incredibly valuable for a decarbonized economy. Given that, we really see hydrogen as being an important backbone to a decarbonized economy within transportation as a fuel for the longest haul, heavyweight, or fast fueling applications. We see hydrogen as critical to delivering energy or power to remote locations or off-road, off-grid locations, whether that's construction or mining or even agriculture, places that don't have grid power access and really need to decarbonize in a way independent from the grid, as well as other important industrial applications that currently use hydrogen as either a reducing agent or an energy source. So we see hydrogen as really an important molecule underpinning a lot of the economy in the future.
I'll summarize it this way. Hydrogen can and will create jobs. What you described, you need people to work there, and the hydrogen can give them the energy in order to create these jobs. Ted, this has been fascinating. I love how the company's named after Jules Verne. For the record, that's awesome. As we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
I think the key takeaway for everybody today is that what we're focused on at Verne is making sure that the hydrogen is actually low cost. That's one of the biggest bottlenecks we see in the industry taking off today. There's been a lot of focus on minimizing the production cost of hydrogen. We're focused on making sure that the delivery cost of hydrogen is also low cost. That's really what matters, is how expensive is the hydrogen at the pump? How expensive is the hydrogen at the off-grid location where you need low carbon electricity? We have to look not only at the production cost of hydrogen, but also at the delivery cost of hydrogen. And that's really what Verne is focused on solving.
Low cost hydrogen scales. When the cost of hydrogen goes down, The technology use cases increase, the adoption increases. Today is tomorrow, tomorrow is today, the future is compressed hydrogen. Ted, thank you so much for coming on SAE Tomorrow Today.
Great. Thank you so much for having me.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week when we discuss the future of over-the-air updates and what software-defined vehicles will look like.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.